So this is part 2 of the beauty of a velocity versus time graph. And in this velocity versus time graph, we're going to be specifically looking at quantifying the amount of displacement. And the displacement from a velocity versus time graph can be figured out by the area under the curve. So remember that the area under the curve is from where your curve or line is to the x-axis. So down if you're in the first quadrant, and then up to the x-axis if you're in the fourth quadrant. Again, my journey is in 4 parts. The blue part here, green, pink, and purple. So in the blue part, I am in the first quadrant of the velocity versus time graph, which means that I'm going forward. I'm going toward the x-axis, which means that I'm slowing down. Parts 2, 3, and 4, I'm in the fourth quadrant, which means that the journey is going backwards. The object is going backwards. So we're going to look at this in figuring out the area under the curve. So this velocity versus time graph, my velocity resembles this graph right here. I'm in the first quadrant, I'm going toward the x-axis, which means that my d versus t graph, if I drew it, would look like this. So it's going forward, has a positive slope, but it starts out steeply and then the slope gradually approaches 0. The area under the curve, because this is a triangle, will be 1/2 base times height. So 1/2, the base is 4 and the height is 15, so that will be positive 30 meters. For part 2, I am now in the fourth quadrant and I'm going backwards, so that resembles this graph right here. So if I were to graph this as a d versus t graph, my line would look like this. It's going backwards and gradually becoming more steep. Because I'm in the fourth quadrant, all of my y values are negative, which means that my area under the curve will be negative. It's not a negative area, it's just the magnitude of my area under the curve will be negative. So again, my base is still 4. It's going from 4 to 8. And my height will be negative 10. So the area will be 1/2 base times height, so negative 20 meters. So I've gone forward, slowing down 30 meters, and now I've gone backwards, speeding up 20 meters. For the third part of the journey, I'm at a constant velocity of negative 10 meters per second. So that looks like this. I'm at a constant velocity in the fourth quadrant going backwards. My d versus t graph would look like this. This is a rectangle, so the area under the curve will be base times height. My base is 4 here, 8 to 12, and my height is still negative 10. So the area under the curve is negative 40 meters. And then finally, the last part of my journey, I'm still going backwards because I'm in the fourth quadrant, but I'm going toward the x-axis, which means that I'm slowing down. So that looks like this purple section right here. My velocity versus time graph is in the fourth quadrant, moving toward the x-axis. This is a general format of what my d versus t graph would look like. So if you wanted to figure out what the net displacement, the overall displacement was, you would simply add up these areas under the curve, values. So 30 plus negative 20 is 10, plus a negative 40 is negative 30, and then plus another negative 10 would be negative, let's see, where did we get? Negative 40. So 30 and 10, negative 30, negative 40. So at the end of the 14 seconds, the object would be negative 40 meters from its start point. So either 40 meters to the left or 40 meters down from the start point. And if I had a sketch of what that would look like, I would be going forwards, slowing down, backwards, speeding up, then at a constant velocity, and then backwards, slowing down. So this is the general format of what my d versus t graph looked like if I were to qualitatively sketch it.